All right, forget what you know about warfare. We're not talking about bullets or bombs today. We're diving into something much quieter. Silent, invisible force. We're talking about directed energy weapons. And believe me, this isn't science fiction anymore.
Seriously, just think about that for a second. What if you could stop a car dead in its tracks, or take a drone out of the sky, or even affect a person with a beam that's completely silent and totally invisible? It sounds like something out of a movie, right? But the crazy thing is, this technology isn't just real, it's already out there being used.
So yeah, this stuff is real, and it's time we understood it. Let's break down the reality of these powerful new weapons, what they are, how they work, and honestly, what this all means for us.
Okay, first things first, let's get down to the basics. What are we even talking about here? What exactly is a directed energy weapon?
Well, the name kind of gives it away, right? Instead of shooting a bullet or launching a missile, a physical thing, a DEW shoots a focused beam of energy. We're talking about pure energy, like super concentrated light or microwaves being used to damage a target.
And they basically come in two main flavors. You've got high energy lasers, or HELs. The easiest way to think about these, it's like a giant, weaponized magnifying glass. Its whole job is to burn things, to melt, crack, or set a target surface on fire. Then you have high power microwaves, or HPMs. These are totally different. Think frying. They're like a super focused EMP blast that overloads and destroys electronics from the inside. So you've got burning on one side and frying on the other. It's a really simple way to remember the difference.
Now, for any of these to be effective, three things are absolutely crucial. First, power density. Basically, how much energy are you packing into that beam? Second, dwell time. How long can you hold that beam on the target? A split second might not do anything, but a few seconds could be devastating. And finally, beam quality. This one's huge. How well does that beam stay focused as it travels? Because if it spreads out too much, it gets weak. You get these three things right, and you've got a seriously effective weapon.
Okay, so let's move from theory to reality. Let's talk about one of the biggest applications for this stuff right now, lasers versus drones. This is where sci-fi truly becomes real.
And the way it works is actually pretty simple when you break it down. First, you've got to detect it. Radar or cameras lock onto the drone. Then, the system points a laser right at it. The key is to hold that beam on one specific spot for just a few seconds. That's all it takes. The intense heat builds up, melts a critical part, and boom, the drone just falls out of the sky.
And I want to be clear, this isn't some lab experiment. These are real operational systems being used by countries around the world. I mean, look at this. China's Silent Hunter can reportedly burn through steel from 4 kilometers away. 4 kilometers! France has a system that works in extreme weather. Australia's can take out hundreds of drones. This is a whole new kind of arms race, and it's happening right now.
So that's the burning part. The lasers you can sometimes see. But what about the invisible frying? This is where things get even stranger, maybe even a little scarier. Let's dive into high-power microwaves. Right. So remember frying? That's what HPMs do. Their goal isn't to burn a hole in something. Nope. Their job is to blast a target with such an intense pulse of microwave energy that it completely fries any electronics inside. We're talking circuits, chips, anything that runs on electricity.
And the power levels we're talking about are just insane. 10 gigawatts. Let that sink in. For a tiny fraction of a second, some of these systems can put out more peak power than multiple nuclear power plants combined. All of that energy focused into one invisible, instantaneous zap. It's mind-boggling.
So how does it actually kill the electronics? Well, that energy is sneaky. It gets inside a device through any opening it can find. An antenna port, a vent, even a tiny seam in the case. Once inside, it creates these massive voltage spikes that the delicate little components just can't handle. It's like trying to force the entire flow of a fire hose through a drinking straw. The result? They just burn out. Instantly.
Okay, so we've established these waves can fry a drone or a computer. That's a huge deal. But it leads to a much more unsettling question. If this energy can do that to sophisticated electronics, what does it do to the human body? After all, our nervous system, our brain, it all runs on delicate electrical signals too.
And that question? Well, it takes us straight into one of the weirdest and most disturbing mysteries in modern geopolitics. You've probably heard of it, Havana Syndrome. It all started a few years ago. American officials, first in Cuba and then all over the world, started reporting these really bizarre, debilitating symptoms. We're talking intense headaches, dizziness, a constant ringing in their ears that wouldn't go away, memory problems. And this wasn't just one or two people. It was a pattern, a very, very strange one.
So, of course, the US government investigates. And after a ton of work, the intelligence community came out with a jaw-dropping assessment. They concluded that directed energy or pulsed RF devices were a plausible cause. Think about that. The official position is that these symptoms were likely caused by some kind of invisible energy weapon.
And that is terrifying, because it suggests that someone has a weapon that can cause actual physical, neurological harm to a person from a distance without any bang, without any bullet, and without leaving a single visible trace. An invisible wound from an invisible weapon.
So you can see where this is going, right? This opens up a massive, massive ethical can of worms. When you have weapons that are invisible and leave no evidence, the potential for abuse is just off the charts.
I mean, look at the two sides of this coin. On one side, you can argue for some sanctioned uses, right? Maybe non-lethal crowd control, protecting a power plant from drones, stopping a car without a dangerous chase. But the sinister side? That's a whole other story. Covert harassment of dissidents, intimidating journalists, causing these mystery illnesses on purpose. The line gets really blurry really fast.
And this is the big unanswered question. Who decides when it's okay to zap someone with invisible energy? Right now, there are no international treaties about this. There are no rules of engagement. So where is the line between a tool for protection and a tool for persecution? And who gets to draw it?
Okay, so with all this in mind, it's easy to feel a little powerless. But what can you actually do? Well, it turns out the principles for protecting against this stuff aren't new. We can actually look to how the military shields its gear from things like EMPs.
The basic concept is something called a Faraday cage. It's really just a shield, usually metal, that blocks electromagnetic energy. Think of it like an electrical force field. On a small scale, this could be a metal enclosure for your router or your phone. You can add special filters to your power lines. And for really critical gear, you can use grounded metal mesh. The idea is to create a barrier that energy just can't get through. So we're back to the big picture. This isn't theoretical anymore. Lasers are actively shooting drones out of the sky, and there's credible evidence that invisible energy is being used to harm people. It forces us to ask a really fundamental question for our time. As these invisible weapons become more and more common, who is going to draw the line between protection and persecution?